Okay.
We're all here, so shouldn't really need the video. But, all right. And the time we needed it, I forgot to start. All right. So, bottom line, with just a quick introduction to this idea of angles on the plane, on the XY plane, the idea of coterminal. This becomes a really critical thing in trigonometry, important for us the rest of the year. Standard position. We have this, what we call the initial side being on the x-axis, like so, and then the terminal side, and we think of this angle as a rotation in the counterclockwise direction is our normal rotation. Now there may be times we go negative, which is clockwise going down. Okay, of course this is always still, no matter which direction we go, this is still quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Those quadrants will be real important for us to understand as we do trigonometry. Now, so we're going to begin in that. Section 1 is kind of a long section. There's a lot of stuff in section 1. Matter of fact, we're going to have our next quiz on Friday of this week, and it's only on section 1. Okay, we're going to be doing section 1 all week. You saw, or you probably saw your grades. We still have somebody to take the quiz. Typically, my procedure is I don't hand back quizzes until everybody's taken them. So we won't get to see those today, but should get to see them here a little bit later in the week. So anyway, I just picked out a couple here. So 510 degrees. We want to be able to, I saw a lot of you on your pictures, you had the curls, the rotation of how many times. Of course, you couldn't do that with all 5 angles, that'd just be a mess. But if you did it, at least with the original angle, that would be good. Show the direction. But these are all names for the same angle, okay? And it's just a matter of adding and subtracting. Now, for this particular one, if we take 510 and we subtract 360, that's still a positive angle. So I think there may have been some confusion with some of you also on that. So the 150 degrees counts as a positive angle, even though I subtracted 360 to get it. Okay? So we're supposed to do 2 positive angles and 2 negative angles. So if I subtract 360, I get 150. So that still counts as a positive. Subtract 360 again, I get negative 210. Subtract 360 again, I get negative 570. There's my 2 negatives. And so then what I'm going to have to do is add 360 on the 510 to get another positive, 870. So I got 2 positives and I got 2 negatives, right? But every time I add or subtract 360, I just go around a circle. I just go around right back to where I started, okay, depending which way we were going, okay? So it is true, if you go 510 in the red here, I go all the way around to there. If I subtract 360, you might confuse that as thinking that's the negative direction. It's the measure that determines whether it's a positive or negative direction. So if I go back 360, my terminal side is still here. If I measure it this way, that's a positive 150. Positive 150. Okay. So anyway, that could be an example for 510. Here's negative 120. So negative 120 means go this direction. And again, always remember each one of these is 90. Okay, so typically what you'll see me doing is, if I've got to go 120, I'm going to say 90 plus 30, right? Or I'm going to say 180 and then subtract 60, right? Because it's going to become important for us to find these numbers in here, right? At some point here in chapter 4, we're going to talk about these pieces here. Even though this is not a 60-degree angle, it's not a 30-degree angle, actually it has a name it's called a reference angle. We have a reference angle with the x-axis, we have a reference angle with the y-axis. But the angle itself is negative 120, 90 plus 30. So it would go about there. So if I add 360 to that, that gives me a positive. Add another 360, I get another positive. There's my 2 positives. If I take away 360, I get that. Take away again, I get that. Okay, any questions on that? Okay, pretty simple really. Coterminal means they share the same terminal side, so they are equivalent as far as where their position is. They're not equivalent in number of rotations, but they're equivalent as far as where their terminal side is in there. Okay, so let's go ahead and just do this real quick, just to practice. Maybe you did this last Friday and it's been 3 days since you did it. So let's do those 4 problems there for a quick little warm-up here. Okay, don't look if you don't want to see the answers yet. All right, any questions on that? Okay, so negative 400. Now again, the most important, the coterminal, I mean, we gotta understand that it's a pretty simple process, really, with adding, subtracting 360. The more important thing is the sketching, right? Negative 400. And you notice I put in the kind of the what I call the reference angle, just to kind of show where it would be. But negative 400, so we're gonna go negative direction 360, plus we gotta go 40 more to get to 400. So it's gonna be down there. Okay, 220 is going to be 180, again, plus 40 more is going to be 220 down in the third quadrant. So one of those is in the fourth, and one of those is in the third quadrant. Okay? All right. One last thing. Oh, oops, I got this in the wrong direction. Here we go. Okay, so this is on page 284, not a big deal, but in the book, one of the but it's something we should jot down here. I'm going to let you do this on your calculator, so if you want to get your calculator out, historically, partial degrees used to be written in degrees, minutes, seconds. It was kind of a navigation thing. It was and part of it is this, because I really think that, you know, if you're way back, why is there 360 degrees in a circle? Why that number? What do you suppose? Yeah. think about the Earth revolving around the sun, which is not really a circular orbit, but and it's 365 days in a year. So roughly, a degree would be like a day. So if you looked at the movement of the Earth in an angle, in much this same circular fashion we're talking about, 365 days in a year, in one rotation around the sun, 360 degrees, each degree being like a day. And so makes sense in that scenario. Now, I don't know what happened to hours, but anyway, breaking up part of a degree or part of a day, minutes and seconds. So a single dash like this is minutes, and the two dashes would be seconds. Okay, and so each minute is a 60th of a degree, and each second then is a 60th of a minute, or 1/3600th of a degree. So back in the day, my day, the old days, we would actually calculate these kind of a little bit by hand. So if we were going to do 64 degrees 30 minutes, we would take the 30 and divide by 60, and so that's 1/2, and so that'd be 64.5. If we were going to do 104 degrees 45 minutes 50 seconds, we would say, okay, that's 104 plus 45 60ths plus 50 3600ths, and then that would be. And then we would convert those to decimals, and we would divide this out, and we would divide this out, and then that would be your decimal version. Okay, now, I'm not going to have you do that. I want to, just as a matter of historical, I want to show you this. But if you go to your calculator, and if you've got one like mine, now the screen's really hard to see here, so I'm going to have to maneuver this around maybe a little bit, but it doesn't really matter if you can see the screen too much. But if I put in here, if you notice, if you've got a TI-30X, you've got a button that has, you have a button that is degree, minute, second. It's this button right here. Okay, now if you have a different calculator, see if you can find it. If anybody has a different one, I may have to help you. Because on Friday's quiz and on today's homework, there might be a couple of questions where we're going to convert back and forth. I'm just going to let you just do it on your calculator. Okay? So the way we would type in 64 degrees 30 minutes is we would simply, as you would think, we would type in a 64, we would hit that button, it would put a degree, or it would give me the choices. So I would want to choose the degree option, hit equals or enter. Then I would type a 30. Then I would hit that button again. Then I would arrow over to the minute symbol. And then I would have 64 degrees 30 minutes. Then when I hit enter or equals, it converts it to a decimal for me, 64.5. Okay? Now if I want to go the other direction, I type in, let me clear that. I just type in 64.5, whoops, 64.5. I hit that same button, but this time I arrow to the right, and if you go off the screen, it's got this with the little triangle and DMS, and that means it'll convert to degrees, minutes, seconds. So now I just hit equals. Now this is telling me it's going to take 64.5 and convert to degrees, minutes, seconds. I hit equals. I get 64 degrees, 30 minutes, 0 seconds. Make sense? Okay. So let's try that. If somebody's got a different calculator, I can try to help you figure it out. But let's try that with those 4 problems right there. So go ahead and just hit equal. Hit this button again. Hit it once, hit it once. let's just. Oh, okay. I don't know why we're getting an error, but. DMS takes it from a decimal, so it's got that triangle with a point. It's telling you it's going to put it into degree minute second. Okay. The other one is to type it as DMS, hit enter, and it'll just automatically go to this. So try this one, okay? So try these next. Okay, so 104 hit the degree, 45 hit the minute, 50 hit the second, and you get 104 point, how much? 76 degrees, okay? So that's DMS to decimal. So now we want to go the other way. We go 56.735, and that's when you do the triangle DMS. And you get 56 degrees, 44 minutes, 6 seconds. Which one? This one is probably Gary. This one would be and I think the second you do 2 so I was going to do 64 degrees. I don't think we go 30 versus this part of the
like the forehead is white and like not like it. I need to know
let's say this be up in the first 2 minutes. No, it's going to be me saying what we're doing in the first 2 minutes. You already have it for minutes.
But if it's not a good one, yeah.
It's the unstoppable.
So I would say use that one. Probably. It's probably on that other one. All right. What's this one? 213.875 and 56.6 whoops, minute, second. Simple. Okay, so we'll let the calculator convert it. Okay, again, it's not something that's very common practice anymore. It's a little more of a kind of a historical thing. It used to be done that way a lot, not so much anymore. All right, so here's the big thing today. So now we spent all this time talking about degrees. Now we're going to get into another way of showing an angle in a circular fashion, in a rotating fashion. And it's called radian measure. Okay? Now, you may have always seen on your calculator this DRG button. And you know how in your calculator there's always this little, if you got one of my TI-30s, it always says DEG at the bottom, right? It's always on there, degrees. Okay? If you hit that DRG button, that switches to what? Hit the DRG button on your calculator.
DEGRAD and GRD.
Just the DRG. Just like, oh, and then, yeah, oh, I see. You're right. I'm thinking of older calculators. You hit DRG, it just changed. So you get DEG, RAD, and GRAD, rad and grad, right? Well, if you arrow over to rad, hit enter, then it changes out of the bottom to rad. Now, we're not going to do that a whole lot, but we may. But it's really important to understand which mode you're in. Okay? All right. Anyway, so here's what we're going to do with our little activity here. Okay? So this angle theta, so we're going to think of a point being on this circle. There is an arc length that is created right here. And as you go around the circle, that length increases. Okay? So the measure of the angle, we can think of it in degrees, where 360 degrees is all the way around. We can also think of it in terms of arc length as the angle. And that has a number of advantages in real life applications. Matter of fact, in calculus, one of the first things I tell students is put your calculator in radian mode and leave it there the rest of the year. Because everything we do will be in radian measure for angles. We don't use degrees ever. Now in this class, we're going to use both. Okay, we're going to be working with both, and we'll talk about when one is advantageous over another. Okay, so everybody needs one of these circle makers. So take one and pass it back. All right, and that piece of paper that I gave you. Now, the way this works, and you can make it big enough to kind of fill your paper. You can make it a little smaller than that, however you want. But the way this will work, we're going to make it big enough that you'll want to, when you put this on your paper in the middle somewhere, preferably in the middle of that plain white piece of paper I gave you, and in the little metallic center of the white one here, pencil in. Now you're going to have to hold it still, but you might pencil in. That'll be your center, and you're just going to put your finger over that. You're just going to put your finger over the middle of the white thing here, and then make sure you go to the thinner or the part that's not the widest on your paper, and just put your pen or pencil in one of these holes, okay? And then you just go around, trying to hold your finger still and draw your circle. And then again, it's important that you kind of mark the center also, okay? So just make yourself a circle. On your paper. Okay, now I'm going to come around and I'm going to cut you a piece of string that is the length of your radius of your circle. So I'm going to hand you the string. No, I'm going to hand you the scissors. Ooh. Yeah, I trust you. I'm going to hand you the scissors. I'm going to put the string that's the radius and you cut it. Okay, and I'll tell you where we're going from there.
Make a small circle.
See my circle?
Okay.
I did mine at this.
I did mine at 2.5.
I did mine at 5.
Mine did 2.5.
Don't mock it.
That's your second?
Yours is at 6. You need it.
Yeah.
What?
No, but I remember Claire saying, I could just stay in the
It's like my nomination. Yeah, both of them.
and their house is right outside.
I'm gonna score 30.
Their house is in Saxon. And
I'm gonna
you have
make
made
sure
promotions.
that it's just you defending.
I have a big two like the really generous, like the dog kennels. And I was sitting in it the other day. I think I'm gonna go to the guy who was hold like.
No, if it's not, they'll be fully stretched out.
He yelled at me to get down today. He's like, I'm here. I like one, and I'm like, honey, I know.
Yeah, so you can get one meter drainage.
You guys know me.
What?
Keep getting 1 meter down, keep it
Just
going.
sitting in my locker.
Oh, yeah, I forgot to tell you, Coach Bull was basically freaking out on me because I have a personal trainer.
Yeah, I don't get
Not
why.
living out here.
I don't get why. Yeah.
He doesn't know that I'm working out here.
Yeah.
Like how?
So that
You have to like do this. Really, like, having a personal trainer is not
You ready?
still, if you put yourself there.
both of our teams are going to make overactive.
Oh. Darn it.
Yeah. Okay, so, you know
I'm not
what?
gonna say that.
You're taking
I'm
that.
just like,
Oh,
That's about right.
I know I'm better than that. That's like I stood up. What's that? You know, that ripper.
Huh?
goodbye. I gotta go to lunch.
I'm underselling myself.
Logan Harder.
You always shoot low, so
Trevor
when it happens,
Robbie Perkins.
Robbie's an athlete. He just doesn't live.
I don't know if he's gonna be playing with us. I mean, I bought him our like special shorts and everything.
You guys bought special
Have
shorts?
you seen them?
They were gonna be tons of fun.
They're like these boxers that put over these and they have like.
All right.
Over and
Now, what I would like for you to do now is use the straight edge part of it, okay? And try to draw as best you can an X and Y axis. Now the X axis is really the most important part. You don't really need the Y axis in there, but put an X axis, okay? So we have an initial side for our angle, okay? Kind of a starting point. Now, what I want you to do Nick, come up here. Come up here, grab the scissors. Okay, cut mine right there. All right, here's what we're going to do. We're going to take our piece of string. Now remember, this piece of string is 1 radius, right? 1 radius is what your string is, okay? I want you to take your string and I want you to start it here at 0, and that's going to be hard for me because it isn't laying down, but you're going to lay the string around the circle, and then you're going to mark where that ends. Like so. And then continue around the circle. Okay? So lay the string starting at 0 and carefully lay it around the circle, mark where it ends, and then move it, and then go around again, and around and around.
How many times? We keep going this button.
All the way around. No, just till you get to where I got to, right? Just like that.
Yeah, because you can't put it in. Because you started there. See what mine is right here. Just go here.
Do I need to erase this one?
Because you started with the first one. Over here, so you can't. If you can't.
Yeah, we don't want to overlap them.
But you don't want to.
So just leave.
So you want to stop right here, down here in the fourth quadrant. Just like that. Now, my question is,
Get rid of
does yours look, see, I've got 6 marks. You should have 6 marks like that. So my question is, are your marks about in the same place mine are?
Yeah.
Is your circle the same size as my circle? I mean, it could be, but probably not. I mean, a lot of the circles are really different. I mean, there were a few of you that had pretty small circle on your paper, and then some that pretty much filled the paper, right? And it doesn't matter. The point is, it doesn't matter. So I always want you to think, obviously the word radian is coming from what? Radius. Because this angle right here, let me put it in blue. This angle right there is 1 radian. That angle right there is 1 radian. It's roughly 57.3 degrees. And no matter how big the circle is, that is going to be the case. Okay? That 1 radian is going to be 1 radius. So whenever we think about radian measure, and whenever we think about where 1 radian is, or where 2 radians are, or where 3 radians are, I want you to think back to this little activity. I want you to think back to the piece of string that was 1 radius, and I'm going to say, remember, when we took 1 radius, how far did it go? And another radius, and another. Okay? Now, there's a couple of things going on here that are important. Okay? So let's look at this picture right here. Okay? Here is what doesn't look reasonable, that here with a radius of 1, that this red length here is the same as this blue length. Seem reasonable. Okay? And it makes, again, about 57 degrees. If I increase the radius of this circle, right? The radius doubles, but then this is going to double accordingly, right? And so the angle stays the same, no matter how big the circle is, okay? And so we still have a measure of 1 radian. Now, and so you guys see this circumference thing that's here. So you might notice that 1, 2, 3 radians is just short of 180 degrees. 4, 5, 6 radians is just short of 360 degrees. What is the circumference? Remember, circumference is the distance around the circle, right? What is the formula for circumference?
Pi r squared.
No, that's the area of the circle. 2 pi r. That is the distance around a circle. So now let's imagine that we had a radius that was 1 inch, 1 centimeter, 1 foot, whatever you want, unit you want to put on it. Let's imagine that our radius was 1. What would be the distance around this circle? Two pi. If the radius is 1, the distance around the circle is going to be 2 pi. Or better yet, if I just divide by r, isn't the circumference divided by the radius always going to be 2 pi, right? So let's say the radius here, this was 3. So 3, 6, 9, 12, whatever. Once I found that circumference, if I divided it by then 3, divided by the radius, right, I would always get 2 pi. So why do you suppose this is a little bit short? Because what's 2 pi? 6.28. Or pi would be 3.14. In other words, the angle around a circle is always going to be 2 pi radians. It's always in radians, not in inches, right? Because that's going to depend. If your circle gets bigger, the distance around gets bigger, right? If your circle gets bigger, the distance around gets bigger. But that's not what we're talking about. We're talking about radians. We're talking about this is 1 radian, so no matter how big this circle gets, right? 1 radian is going to be there. 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, 0.28. 6.28 radians. It is always going to be 6.28 radians around a circle. That is defined to be. Just like degrees is this kind of made out of thin air number that, since it takes us about 360 days to go around the sun, we're going to call one full rotation 360 degrees. That's kind of a made up thing. Well, that's kind of where this comes from. We're going to say 1 radius. So around any circle, it's 2 pi radiuses around the circle. Yeah, because that's what circumference is. 2 pi radiuses around the circle. Okay? And so we're going to call that radian measure in a circle. Okay? Now, so I kind of jumped ahead here a little bit, but so this is a way to measure angles. 1 radian is the angle created when the radius and the intercepted arc have the same length. It should be half, isn't it? 1 radian is the angle created when the radius and the intercepted arc have the same length. Okay? That is 1 radian. Now, we are oftentimes going to talk about our angles in radian measure in terms of pi. Like 2 pi, or pi halves, or pi thirds, or pi sixths, or pi fourths, or something like that. But we wouldn't have to. We could talk about it as decimal. Instead of pi halves, we could say 1.57. Right? Doesn't it make sense? Doesn't it make sense that this would be pi halves? If this is 2 pi all the way around, this is pi halfway around, wouldn't this be pi halves right here? And wouldn't it make sense that that's about 1.57? If this is 1 radian here, and this is 2 radians to here, doesn't it make sense that that's about 1.57 radians? Okay? And this is 3 to here. It makes sense that this is 3.14 radians around to there. Okay? All right. And this would be what? 3 pi over 2, 1.5 pi. That'd be 3 pi over 2, 1.5 pi right there, which is about 4.71. If you take on your calculator 3 times 3.14, divide by 2, you get 4.71, and that makes sense. 1 radian, 2 radians, 3 radians, 4 radians, just short of 5 radians. 4.71. Okay? All right. So we did this. All right. So there's our picture there. That's kind of the picture we have. You can hang on to that circle if you want. You know, these are going to be kind of some important numbers for us to remember. Okay? But 1 radian, another radian, another radian. All of those are about 57.3 degrees, which makes sense because it's a little more than 6. 360 degrees. 6 of those, all right, 360 divided by 6 would be 60 degrees, but it's a little more than 6, so the angle's a little less than 60. So you take 6.28 times 57.3 degrees, that'd be 360 degrees. Okay? All right, so as we go around the circle, that's just another way to measure this rotation. Okay, instead of in degrees, we can measure here. Now again, you might be wondering, why do we need this? Why can't we just use degrees? We're used to that. Well, there's a lot of formulas that involve this relationship, this circular relationship here. and the arc length around the circle. And they're much more simple formulas if we use radian measure as opposed to degree measure. Okay? They're much easier to work with. All right, now, so again, this is, you don't have to write this down, but this is just the kind of that picture I was doing when I was making the circle bigger. Notice, it doesn't matter. Some of you had small circles, some of you have big circles, some of you have in between. Here, it looks, now, mine's not big enough, mine's not 1 radian, it looks like mine's a little less than 1 radian. It looks like this arc is not quite as big as the radius. Okay? So, another way to think, and this would be a formula you could write down, so in radian measure, this is the arc length, S is the arc length, and this is the radius. Okay? So if we just take the arc length divided by the radius, that is our angle. So if the arc length and radius are the same, we said that's 1 radian. S divided by R, if they're the same, that's 1. If the arc length is twice as much as the radius, that's 2 radians. If the arc length is 3 times the radius, that's 3 radians, and so forth. But if it's somewhere in between, we just divide, and that would give us our radians. So it makes it easy then, we just multiply both sides by R. Right there, that's one formula right there that shows you that's a lot easier than arc length. In geometry, here would be your arc length formula. It would be your central angle divided by 360 times your radius. Okay? That would be your arc length in degrees. Okay, so if you had a 60, right? If you had a 60 degree, so you would have to do that. Well, no, I think it's not even that easy. It would be 2 pi. I got that wrong. It's not theta. It would be 2 pi r times theta, or 2 pi r theta divided by 360. That would be your arc length in a geometry sense. In radians, it's just that. Just your radian times your radius gives you your arc length. Okay, so that's a formula we'll be dealing with as we go along. Okay, got just a little bit of time here, so let's go to this, the next thing that then we'll continue over lunch, and this will be a lot of what your homework's going to be about. Okay, so if theta is the ratio of the arc length to the radius, okay, if they're equal, it's 1. That's 1 radian. That's what we were just talking about. So 1 full rotation, circumference 2 pi r, divide by r. So I did my arc length. So if I go all the way around, my arc length is 2 pi r, right? If I go all the way around, let's go this way. Go all the way around, that's a full circumference. That's 2 pi r divided by r. So 2 pi, right? So again, same thing we've been saying, nothing new there. All the way around is 2 pi. So the conversion factor for us is going to be this. So one thing we want to keep in mind then always now is 2 pi radians is equal to 360 degrees. So what we want to be able to do is convert back and forth between those. Okay? 2 pi radians is the equivalent of 360 degrees. Okay? These are both theta now. These are both angles. So it's even though radian measure is technically an arc length, even though theta is an arc length, it's the arc length divided by the radius. Okay? But it's giving us the same as that rotation did in degrees. Okay? So if we're doing degrees, we would think of this as a rotation, like so. If we're thinking arc length, if we're thinking radians, we're thinking this divided by that. We're thinking S divided by R. Okay? But it's still the same spot on the circle. It's still the same spot on the circle. All right. So if 2 pi radians is equal to 360 degrees, then that means pi would be equal to 180 degrees. Okay? Just divide both sides by 2. So this is the one that I always remember. So if I'm converting back and forth, I always just keep in my head, okay, pi is equal to 180 degrees. Now yes, pi is still also equal to 3.14, but that's just another name for pi radians is 3.14 radians. Remember when you went around the circle, 1 radius, 2 radius, 3 radius, it was a little short, right? 3.14 radians. That's the same as 180 degrees. So that means pi over 180 would equal 1 radian per degree, or 180 over pi would be 1 degree per radian. So we can use that as a conversion back and forth. Okay? And so we're going to use that to do a couple. So since we just have a minute or two before the bell, let me just give you one real quick one here. So if I ask you for pi fifths, that's radians, what is that equivalent to? Think about it over lunch. Thanks, Dr. Recording. Thank you. All right, so far basically we've done two things today. So we first talked about degrees and how we can take partial degrees and convert that to degree, minutes, seconds. So we're going to be several types of converting that we're doing. Now this is a whole different converting. We're going to be converting from degrees to radians. So that's changing units. It's kind of like going from inches to centimeters or something, right? Now degrees, minutes, seconds, that's just a way to do partial degrees, right? Instead of decimal degrees to do, so that's a different scenario. So that's degree, minutes, seconds is still degree units. All right, now with radians, now you notice I wrote radians here. Normally we will not write radians. Notice I didn't write radians here, right? Well, when it says pi, we assume that's radians. Right here I wrote pi fifths rad. We normally would not do that. Okay, we would just write pi fifths, right? And that's just assumed to be radians. To be honest, radians is really a unitless measure. Because if you think about it, the formula is, this arc length could be measured in inches, and so would the radians. So inches divided by inches, they're going to cancel. So really, radians is a unitless measure. It's about the rotation. Degrees will always put the degree symbol on. Okay? But in radians is just a real number. So if we say, like here, theta equals 3.14, there is no unit to go on that. Now you could write radians, that's fine, but it's not really a unit like degrees is. Okay? It's kind of a weird thing. You think, well, why not just call it radians? Well, it's not. It's like inches divided by inches. It's a ratio of two lengths, right? It's a ratio of two lengths, and so it's just a number. Just like, if the ratio at the dance of girls to boys was 2 to 1, it was 2, or 1 to 2, or whatever, 1/2. That's just a number, right? There's no unit that goes on that. Okay, and it's very similar to that because a radian measure is a ratio of S divided by R. All right, so sometimes these are used as conversions. So if you're wanting to convert pi fifths into degrees, which one of these would you multiply by? The second one. Because this is radians, if you want to write that, and then this one would cancel the radians. So if we take pi fifths times 180 degrees over pi, what we're doing is this is degrees per radian, and so radians would cancel, I guess, radians, if you will, and you're left with degrees. The pi's would cancel. It ends up being 180 divided by 5, which is what, about 36 degrees? So pi fifths radians would be 36 degrees. Now, I'll be honest, I don't like using this one especially because I just like to go back to this and just do substitution. If you've got pi divided by 5, just substitute, just take pi out, put 1 in its place. 180. So anywhere you see pi, just throw in a 180. Okay? So pi divided by 5, if I were doing it, I would just do, that's 180 divided by 5. Okay, that's 36 degrees. So just substitute pi and 180. Now, when you go the other direction, that's a little harder to do. So let's do a couple of these. Let's do a couple of these together. What's that? Okay, we'll be fine. Okay, we'll get there. Okay, now, well, first of all, before we do this, maybe we might want to. This is what scared you? Okay. So let's face our fears right here. Head on. Let's take it head on. Okay, so let's look at this circle right here. Okay? So on the black around the outside, what I've done is I've tried to label what we will get to know as kind of our basic angles, or more elementary angles, or the angles that we're going to memorize some things about. Okay? And we'll practice this over a long period of time. So let's do the black around. Okay, so 30 degrees. And you all remember from geometry, 30, 60 triangles, 45, 45 triangles, right? Those were values that we kind of knew some important things about. So if I go around the circle in degrees, 30 degrees, 45 degrees halfway, 60 degrees, okay, those are 15 degrees apart, so they're a little closer, right? 15 degrees is not really that important of an angle, 75 is not really that important of an angle, so we don't include it in there. Of course, 90 degrees, and then we keep going. Another 30 here would be 120, 135, 150, 180 here is an important one, and then again, 30, 45, and 60, so 210, 225, and 240, there's 270, and all the way around. The radian equivalents of those, and again, remember, pi is 180. So 30 degrees, pi divided by 6. Right? Pi divided by 6. 180 divided by 6 is 30 degrees. 180 divided by 4 is 45. 180 divided by 3 is 60. Okay? And then 180 divided by 2 is 90, like we were talking about. Okay, remember, all the way around is 2 pi. Just like we did with the string. 2 pi is 6.28. Okay? And it took a little more than 6 radiuses to go around the circle. So all the way around is 2 pi. So, and this is pi. So this is half of that. And this is half of that. So that's pi fourths, right? Makes sense. So that's where these come from. Okay. Now, these will get a little more, easier to do as we go along. But if this is 120, that's 2 60s. So that's 2 pi thirds. Okay? 135, that'd be 1, 2, 3 45s. Well, each 45 is pi fourths, so 1, 2, 3 pi fourths. Okay? Pi 6, 30 degrees. 150 is 5 of those. That's 5 30s. So that'd be 5 pi 6. And then all the way over here is pi, and then so forth, so on, all the rest of the way around. Okay? All right, so we will get very familiar with these fractional units of pi with radians, because we'll just practice it over and over and over. All right, so let's talk about doing this. So the easier ones to do are the bottom ones, so let's do those. Okay, so convert this. So 5 pi 6, so this is going to be a big part of your homework tonight, is this conversion. So 5 pi 6, let's convert that to degrees. So that I think the easiest way to do it is a substitution. So what are you putting in for the pi? 180. So take pi, substitute a 180 into there, and you'll get to use your calculators, 150 degrees. Okay, 150 degrees. There's not really a conversion on the calculator. There is. Going in one direction, you can make it work on a calculator, but it's way easier to just do this. Okay, and especially depending on the calculator. Okay, so definitely just want to do it this way. Okay, what about negative 3 pi half? Substitute a 180. What do you get? Negative 270. Okay, and again, do them in your head. Really, the easiest thing, if you're doing it in your head, instead of multiplying first, divide first, right? Which is perfectly acceptable to do. You can just do 180 divided by 6, which is 30, then times the 5. Here you can do 180 divided by 2 is 90, then times the negative 3, right? So you can divide by the bottom number first before you multiply. Okay? All right, now what about these? Well, these are a little trickier. Here's where you probably want to remember this one. This is why I'd like to not do this one. Okay? Because when we want to go from degrees to radians, we want the degrees to disappear. We want degrees to cancel. That's how I always remember to have degrees on the bottom. Because I want the degrees to cancel. Okay? And when you use both of these as your conversion, then you often forget which one to use. So for me, I'm always going to, when I see a pi, I'm going to substitute a 180. That's all I do. And when I see this, I'm going to multiply by this. So if you just remember pi over 180, pi over 180, The degrees will cancel, okay? And then it's just a matter of reducing the fraction, which again, your calculator can do for you, right? You can put in 12, ABC 18, right? You don't have to. Now, there may come a time though, and what, 3 goes into both of those, 6 goes into both of those, 2 pi thirds, right? 2 pi thirds. Okay, negative 45 degrees, we're going to times by pi over 1/8. Degrees will cancel. So 45 into 180, 5 goes in there 9 times, well 9 goes in there 5 times, 9 goes in there 20, 5 goes in there once, goes in there 4, so negative pi fourths. Now, to be honest, the more we work with them, the more you're just going to know 45 is pi fourths. I mean, they're just going to go hand in hand. 45 is pi fourths. Right? We're just going to know. So we see negative 45, so it can be negative pi fourths. But here in the beginning, this is the conversion that you do, and then you reduce. But again, you can use a calculator to help you reduce. All right, now there will come a time where we'll probably do a quiz with no calculator. We may do a quiz just about these different values, memorize them, where are they, and we get into the sine and cosine stuff. Okay, so there will be a no calculator aspect, a memorization aspect of this. And you really need it. I mean, in calculus, it's sometimes in regular advanced math classes, they let them use a copy of their unit circle or this circle we're talking about with these values, like on quizzes and tests, and it always kind of comes back to haunt them in calculus class. Because there is, on the AP Calc test, there's no calculator part and a calculator part. And all the questions on the AP test where they ask you trig type questions are all on the no calculator. They want to see that you know these values. So we're going to make sure you do. Okay, we're going to work hard at that and make sure we leave here good. Okay, you guys try these. So we're either substituting a 180 in for pi, or we're multiplying by pi over 180. Those are the two strategies. We're substituting a 180 in place of a pi, or we're multiplying by pi over 180. Okay, so the first two we're going to multiply by pi over 180, right? We want the degrees to cancel, so we want the degrees in the bottom. So we want 180 degrees in the bottom, okay? So we multiply by pi over 180, 7 pi 6, and negative pi thirds would be the two, right? Negative pi thirds. So we would, I guess I didn't show any work on this one, but pi over 180, 60 goes in there 3 times, negative pi thirds, right? Reduce. Here we just substitute a 180 in there. 180 divided by 3 is 60 times 4, 240. Substitute a 180 in there. 180 divided by 6 is 30, negative 30. Okay? Again, never forgetting though, why do we have pi in here? Why is pi in here? Because of what we did with the string. Radian major. 1, 2, 3, almost gets you there. 4, 5, 6, almost gets you there. 6.28 is what we need. 2 pi all the way around is the same as 360 degrees. All right, now, here's the only one that would be tricky is when you don't have pi in it. If I give you a radian, because remember, pi is just 3.14 radians. 6.2 pi is just 6.28 radians. So what if I gave you 5.75 radians and wanted you to give the angle? Now, my hope is right away you would know what quadrant that's in. What quadrant's that in? Fourth quadrant, right? Because 1, 2, 3, 4, 5, 6 almost got us there. Okay, that's going to be in the fourth quadrant. So we'd expect something over 270, something between 270 and 360, right? What are we going to do to convert that? We can't just put a 180 in for the pi because there's no pi in it. So what do? That's the case where we do have to multiply by what? Well, what do we want to cancel? What do we want to cancel? The radians. So what has to go on the bottom? Radians. So pi is the radians, and what goes on top? The degree. 180. Now you could do 360 over 2 pi. You just need a ratio to multiply by. So what have we been doing on this one? We multiply by pi over 180. We want the degrees to cancel. Okay, it just goes back to this screen right here. I said I normally don't use this because it gets confusing. I just do substitute a 180 in for pi. But if I give you a radian that doesn't have pi in it, just a decimal radian, then we got to be able to do it. Okay? So now we would go ahead, so now take 575 times 180 and divide by 3.14. Right? Or hit the pi button on your calculator. What do you get? $329.45 degrees, which makes sense. That would be in the fourth quadrant. Question, Noah?
Yeah, so then can you just divide it by 2 pi and then multiply by 360?
Right, okay, very good. I know where you're coming from. So here's what you're thinking. You're thinking, okay, 5.75 is part of a whole circle. It's not all the way. What fractional part is it? It'd be 5.75 divided by 2 pi, right? 5.75 divided by 6.28. That's the fractional part of the circle it would be. And then times that by 360. So think about what that'd be doing. That'd be taking 5.75, dividing by 2 pi, and then multiplying by 360. Isn't that the same thing I had to do? They're the same. That's fine. I don't care. I'm not going to check your work and show that you use this. That's fine. Yeah, I like that. Because what that tells me is you know what you're doing. You understand what this means. You understand that 5.75 is almost all the way around. So if you do, to me, if you do 5.75 divided by 6.28, that tells me you're finding the fractional part of the circle you're dealing with, and then you're timesing that by 360 degrees in a whole circle. That gives you where you're at. I think that's a great way to do it. I think that's a great way to do it. But it's essentially doing the same thing. Okay? But I'm fine with that. Now, I'm not going to give you that often. To be honest, the vast majority of the time, we're going to deal with our radian measures in terms of pi. So they're going to have pi in the vast majority of the time. So you'll just be able to substitute a 180 in for pi. Okay, we'll skip that. We got it. Okay, so you can do this right here. Okay, 57 through 87 odd. If they ask you to do degree, minutes, seconds, just go on your calculator. I think the directions actually say don't use your calculator, but ignore it. Okay? For degree, minutes, seconds, go ahead and use your calculator. Okay? So it's not a real long assignment. It's a lot of this just converting back and forth stuff. A little bit of coterminal, I think, maybe in there too. Okay? But we want to get comfortable doing that. Now, again, on my calculus assignments, I usually, because I've done it for so long, I kind of give it to them weeks ahead of time. Here I'm kind of deciding as I go along how much we want to do each day. But On those, I always say, when I give them the assignment, I say this is the minimum to do. So on this one, it certainly wouldn't hurt you to do the evens too, or some of the evens if you're struggling with them, if you're not sure. Because this converting back and forth needs to become just automatic. Okay? And some of you are going to need just a little bit of practice to be fine. But be honest with yourself, if you need a little more practice going back and forth, doing some of the evens in here wouldn't be bad. It's not very long, so.